So now we are in this part in the chapter 2.5. It's the transformations of all the possible functions. And what is all the transformations when I talk about vertical dilation, horizontal dilation, vertical translation, horizontal? Let's see it in this part. So if I have a function f of x, what does it mean? How can I see the horizontal translation? For when I have f of x minus h, it's a little bit like when I'm talking about the vertex. So the formula is f of x minus a number. So this number h is the horizontal translation. When this number is positive, it means I'm going horizontal. What does mean horizontal? Look at the horizon. The horizon, when you look at it, you look like this, like a straight line, like this. Is not a vertical. So when h is positive, so I need to move h units to the right. If f of x equal x plus h, it means it was x minus h. So the horizontal translation is minus h. It means I'm moving h units to the left. So this is the first part is the horizontal translation. Now let's see the vertical translation. Translation when I'm moving up and down. So if I have it outside the numbers, when I have f of x plus a number or f of x minus a number, this number here represents the vertical translation. So 8 units up, or here it's minus 8 means minus 2. It means, for example, I go 8 units down. So this one is called the vertical translation. Now, what does it mean vertical dilation? Vertical dilation, vertically, it means that's y. So I'm multiplying the y by a factor. What is this factor? It is the constant here next to it. So if I look at the vertical dilation, y equal a f of x, look at it. A is being multiplied by f of x. It means I'm multiplying it by y. That's why I multiply the y. I'm taking a positive because when there is a minus here, it's a reflection. So when it's minus here, reflection with respect to x prime or x. So I took all the time the factor as a positive number. When this number is bigger than 1, so I'm multiplying y by a number bigger than 1, what's going to happen? It's a vertical stretch. What does it mean? The graph will be closer to y. So if you are stretching your hand, this is you here. If you are stretching your hand, guys, it's going to be closer to your head. So it means it's a vertical stretch. And when a is between 0 and 1, so it's a 0 point something, we call it vertical compress. If someone will beat you on your head here, you will open your hands like this. So it's going to be far from y prime or y. You're going to be closer to x prime or x. The most important thing is to know how to graph it. So when I say vertical dilation, I'm multiplying the y by this factor. Horizontal dilation, it's when I'm multiplying x by a factor. See it? I'm multiplying x by a factor here, by a constant. So if a is bigger than 1, we say f of x is compressed by a factor of 1 over a. So I will multiply x by 1 over a. And when I will look at the graph, so to be able to graph it, you see how to do it in the graph. When a is between 0 and 1, it's called f of x stretched by a factor of 1 over a, so I will be closer to y. All this we will do it in the application and you will get it, guys, don't worry. This is one of the example. I gave you this function f of x, and I want you from this function that is defined over minus 2, 6 to draw for me 2 f of x, f of minus x, f of 2x, and f of x minus 1 minus 3. We'll do all the 4 steps, and you will see you understand all the concept. So if I want to draw 2 f of x, what does it mean? 2 f of x, I'm multiplying y, so it's a vertical translation, okay? And I need to multiply y by 2. How we will do it? The x will not change. What's gonna change is y. It means, for example, I start with this point. This point x is 0, y 2. I will multiply it by 2, so it's gonna become 4. So this point gonna be here. Let's take all the time the ending of the function, so we'll draw it properly. This one, x minus 2, y 3. So I will multiply by 2 the y, so it's gonna be 6. So it's gonna be here. So I can see that this part becomes here, guys. Do you see it? I'm done with the first part. Now let's move to the second part, this one here. All this part, y is 2, so I multiply it by 2, so gonna be, all this part gonna be 4. I'm okay, I'm done. And then now the last part here, guys, the last one here. So I have x5, y is 1, so it's gonna be times 2, it's gonna be 2, so it's here. So this point here for x6, y is 0. And 0 times 2, it's gonna stay 0. So this one gonna stay in its place. And that's it. So my graph of 2f of x is this one, the red one. So this is f of x, this is 2f of x. Now let's move to f of minus x. So we said that here it's a symmetry with respect to y prime and y, because x was positive. Now x gonna be negative. It means this part gonna be on this part, this one gonna be here, so it's gonna flip, like I'm doing flipping. Like if I will um I have a paper and I flip it on this one, it's gonna be on the other side. So this point gonna be here. The point that is on the y-axis will not change. So the first part's here gonna be here. The horizontal is very easy. It's gonna be the symmetry of 4 is -4, so I am here, so this one is here. This part is gonna be on the other side. How are we gonna do it? This point is here. This point 6 gonna be -6. When I say symmetry, it means the same distance. So from here to here, I have 6 units. So from here to here, I need to count 6 boxes. And that's it. So the red part, or the red figure, represents f of minus x. Now let's move and do f of 2x. Here it's a horizontal dilation. It means I need to multiply the x by the factor of half. Excellent. So what's gonna happen? It's not gonna be smaller. It's gonna be smaller, the figure. So let's say here, let's see the ending for. So for x minus 2, half of it is gonna be what? The y is still the same. Y is 3 minus 1. So this point is gonna be here. This one will not change, guys. X0, half of it. So this part, it's here. I'm done. Now all this part here. For x4, I said half of it, 4 over 2, 2. So this one gonna be here. So it should end here. So all this part is here. And I still have the last one here. X2, half of it, 3. So here. And then this part gonna be here. And then the red one represents f of 2x. I hope you got. I will repeat it again, guys. If you feel that you didn't get, I will repeat it again. It's a little bit complicated. I will do the ending first. So it's better to see the ending point first. So I will repeat it again. This point is x minus 2 y3. The x gonna be half. Half of minus 2 is -1, 3, so it's gonna be here. This point x0, 0 over 2, it's the same, so it's still here. So this part is here. Now this part, it starts with here, it's end at this point. So where it's gonna end if f2x, 4 over 2, 2, so it's gonna end here, so that's it. And here this part, where it's gonna end, it should start from here, 6 over 2, 3, it should end here, so that's it. And this is the graph of f of 2x. The last one, x minus 1 minus 3. So here I have 1 unit to the left, 3 units down. The best way is to take a point and move it. Let's start with the ending. This one, 1 unit to the left, 3 units down, 1, 2, 3. So this one gonna be here. Now let's take this one here. 1 unit to the left, 3 down, 1, 2, 3 here. So this is the first part. Now this one here, I'm still here. This one, where it's gonna be? 1 unit to the left, 1, 2, 3 down. So this line is here. And this one unit to the left, 3 down, 1, 2, 3. So this part is here. And I'm done. This one, the red one represents f of x minus 1 minus 3. Now let's move to the transformations of 1 over x. So the general transformations are in the form of y equal a over b x minus h plus k. What represent all those letters? A is the vertical dilation. Again, I will multiply y by this constant. B is, we call the reciprocal horizontal dilation. We multiply x by 1 over b. H, it's left or right. If it's h here, h unit to the left, to the right, sorry. If it's plus h, it means minus h, so to the left. And then plus k, it's up and down. So this is the vertical, this is the horizontal. H unit to the right. And if it was plus, we say h unit to the left. And let's do this example so you will understand everything. If this is the graph of 1 over x, and you know that 1 over x is a rational function that has a vertical and horizontal asymptote. If there is a translation, if I'm moving the graph, I should move those first. Now here I don't have any translation. I have a time, so I have a vertical dilation. Vertical dilation means I will multiply y by 2. So for the point, for example, 1, 1, it's going to be 1, 2. So this point is going to be here. For this point, for example, 2 half, it's going to be 2, 1. This point is going to be here. I can take another point, for example, this one, half 2, it's gonna be 4, so it's here. And that's it. And all what you need is to join this function, the points, and also it's gonna stay horizontal asymptote. I do exactly the same here. So -1, gonna be -1, -2. This one gonna be here, and exactly the same. I join the points. I can take more points, sure, and then I can graph it. So the red one represents the 2 over x. Now, if I want to do 1 over 2x, so here we call it horizontal dilation. Horizontal dilation, it means I need to multiply horizon x by half. It means it's gonna be smaller. Can I put that zim, guys? It's gonna be smaller. So x11 is gonna be half one. So this point 1 1 gonna be here. 2 half, it will be 1 half. So this one gonna be here. So the function here, this part's gonna go like this, and also gonna continue as a horizontal asymptote. Exactly the same here. Minus 1 gonna be minus half here. Another point, minus 2 gonna be minus 1 here, and then also I'm multiplying x by minus half, and then the function gonna be like this. Sure, as I said, in the class we will do more practice, you will get it easier and easier. The last one that I want to do, if when I have more order transformations, the best way to do the best transformation is first to move the asymptotes. When I say here, I have, what are the transformations I can see here? I have 2 units to the right and I have 1 unit up. When the function is moving, sure, the asymptote will move with it. So the best way is to move the asymptotes first. So the vertical asymptotes need to move 2 units to the right, because if I want to find the domain of the function x not equal to 2, it means the vertical asymptote, it's now x equal to 2. So this one is here now. So this is my vertical asymptote. The horizontal asymptote gonna move 1 unit up. So my horizontal asymptote is here. And now I know that the two functions gonna be here. Now how gonna move it? You take points, guys, it's very easy. This point, 1, 2, 1, so it's here. Let's say this point, 1, 2, 1, so it's here. Let's say, for example, this point, it's gonna be approximately 1, 2, 1, so it's here. And then I join, and then this is the first part of my graph, and then I'm gonna move this one again. See, this is the vertical horizontal asymptote. So this point, 1, 2, 1, so it's here. For example, this point, 1, 2, and then 1, approximately it's here. This point, for example, I have approximately, let's say 1, 2, 1, so it's gonna be here. And then I can join all the points. I know approximately the shape, even if it's not 100% accurate, but at least I know that what I did here, I moved 2 to the left, 1 up. So you move the vertical asymptote and horizontal asymptotes first, and then you do your transformation. If there is, guys, any dilation, you do the dilation first on it as it is. So let's say you have 2x here, you first do the dilation. So this one, you change it as a dilation, and then you move it. For example, you do it like this, and this one you start to move it left and up, or right and up or down. Clear? This is the last part in this lesson. As I said, we're going to do more and more application in the class. Don't forget, guys, to like, subscribe, and share all my videos.